Today we're going to continue our look into linear functions, and there's a special type of linear function that is called a direct variation. And we talk about direct variation with an equation, and if you'll see right here, it's y equals kx. And the significant part here is the k. Let me get that for you, the k right here. Alright, and the k can be any number except 0. Please notice right here, any number except 0. Alright, the k, if you remember, let's go back and look at this, the slope-intercept form, y equals mx plus b. The k is essentially performing the same function as m, but with a special consideration that it cannot be 0. And b, in this case, will always be 0, so we don't even include it. So it's y equals kx. Now, here we have this, k can be found by the following equation, k equals yx. Let's look at what we had in our first sentence there, y equals kx. And if we're going to solve for k, we need to get k by itself. Well, if these are multiplied, what we need to do is we need to divide both sides by x, and what that gives us is k is equal to y divided by x. Y divided by x. Alright, let's put this into practice. Example 1. Julio's wages vary directly with the number of hours that he works. If his wages for 5 hours are $29.75, how much will they be for 30 hours? Well, I'm going to show you the easiest way, and really the key here. Whenever you see varies directly or vary directly, I want you to start thinking proportions, because we can find these as a proportion. So let's put, we've got x's number of hours and the pay. So if I have pay over hours, okay, then I could do this. We know that $29.75 for 5 hours, and then we know the hours. We know the hours would be 30 here, and so we're going to solve for y, Julio's pay. Alright, notice we've got y over x, but we can find this with either one. If I simply divide 29.75 by 5, what do I get? Try it at home. I get $5.95. Alright, if I did the cross multiplication, if I did 30 times 29.75, that gives me $892.50, and then I divide by 5, I come up with my answer here. Y, of course I jumped ahead of myself a little bit, is $178.50. Alright, so really, let me jump back. My equation, write the equation, it would be y equals 5.95 times x. And we found the pay up here with our proportions, $178.50. Now what I could have done is I could have come back and plugged in 30 here and done 30 times 595. Alright, example 2. If y varies directly with x, so here we have our clue, y varies directly. So that's telling me, first thing I'm thinking is I need to do some proportions. So I'm going to put, my first one is here, 28 over 7 And that's going to be equal to 52 over some x value. And notice here it says find x. So we know we're going to have to write the x. So 52 times 7, and we're going to divide that by 28, and we come up with x equals 13. Alright, time for a little practice. So it says a standard shower head uses 18 gallons of water in 3 minutes. So I'm going to look here. I have 3, and there's 18. So I need to figure out what is the rest of this, but we're going to find our K first. Alright, so if I divide, let me finish reading. Complete the table below that shows the gallons used Y is a function of the time of the shower X. So the K, let me just do 18 divided by 3 equals, and this is using our formula, K equals Y divided by X. So K equals 6. Alright, so my equation is Y, my dependent variable, gallons, is 6 times my independent variable, minutes. Alright, I can plug this in. Oh, well, let's fill in our table. So all I need to do here is I need to plug in, what is 6 times 6? It's 36. What is 9 times 6? It's 54. And if I really wanted, I could go ahead and I could plug this into my Y equals and fill out my table. So that's exactly what I'm going to do with my calculator right here. And I'm going to look. 9 is 54. 12 is 72. 15 is 90. 20. Well, that's 120. I should just know that. 120. 25. But I'm going to use my calculator just like I want you to. 150. And 30 is 180. So it says, if 270 gallons were used, how many minutes were spent in the shower? So all I have to do is plug in 270 from my Y, and I'm going to do that over here on the left side, 270, and then I'm going to divide by the 6, the K, because I want to figure out my X. So 270 divide by 6, 70 divided by 6, as you can tell I'm doing this on my calculator, is 45. Alright. Cynthia charges $4 an hour to walk a dog. How much would she charge for 2.5 hours? So my K, and here this and, tells me that we've got my independent variable right here. And then normally I would say slope, but here it's K, so it's 4. My equation is Y equals 4X. And so what I would do is I would put in here 2.5 times 4, which is 10. It takes Maxine 2.5 hours to bake a cake. How long would it take her to bake 4 cakes? So this is each cake. So I'm going to put in here 2.5. My equation is Y equals 2.5x. If I put in 4 in place of the x, 2.5 times 4 is 10 hours. This should have been $10. Alright. 4. This is, here we go, we see this per. So, my independent variable, right here, minutes. Ordinarily my slope, but in this case my constant, 45, Y equals 45x. And then this is asking 3 hours. Well, notice we have minutes over here and hours here. So what we have to do is we have to figure out how many minutes are in 3 hours first. Well, if you figure that out, it's 60 minutes in an hour, so that's 180 total minutes, and we're going to multiply that by 45 words. And we get 8,100. All right, I think you're probably getting the idea here. It takes 2/3 of an hour for Chad to wash and wax a car. How long will it take for 7 cars? So here is our constant. Y equals 2/3 x. So now I need to plug in 7. Now is 7 the y or is it the x? It's 2/3 of an hour for Chad to wash and wax a car. 2/3 for 1 car. So I'll plug it in for the x. So if you want to do this at home, it's 2 divided by 3 and then times 7 in your calculator, and you come up with something that looks like a repeating fraction, and that 0.666666 is actually another way to express 2/3. So it's 4 2/3 hours. And if we think about it, 2/3 of an hour is 40 minutes. So I could also say this: 4 hours and 40 minutes. All right. Solve using proportions. Assume that y varies directly with x. So remember, we're going to do the first one right here. If when 27 over 6 equals, and then y is on top, 45 over x. So we're going to cross multiply 6 times 45, and I can put this all in my calculator, and I'll just put it in like this: 6 times 45 divide by 27. So try that in your calculator at home or wherever you're doing this. You don't even need a graphing calculator. 6 times 45 divided by 27, and that gives me a nice round number of 10. So look here, we're looking for y. So we're always setting this up with y over x. So I have 2.5 over 0.5 equals, now I don't know what y is, so I'm putting that up there, and then I've got 20 here. So the way I do this is I'm going to cross multiply, there we go, 20 times 2.5, and then divide by this, and I can just put this straight into my calculator as 20 times 2.5 divide by 0.5. So let's do that. 20 times 2.5 divide by 0.5. And that gives me an answer of 100. Okay, we've got a couple more left here. 4 over 12 equals, and then we have negative 24 here, and then a y. Then I'm just going to set these up. I want you to solve them at home. If y equals 80 when x is 32, so we're going to find x when y equals 100. If y equals negative 6 when x is 9, find y when x is 6. So if you will do that, and just an example, negative 6 times 6 divided by 9, the last one would be negative 4. All right, you have to fill these in, and you can bet that I'm going to have you fill in your answer for those on a quiz.